Good day to all. The World Vegetable Center, one of the international agriculture research centers focusing on vegetable research and development and headquartered in Taiwan, has been collaborating with the Tamil Nadu Agricultural University in Coimbatore to implement a project on integrated pest and disease management in vegetable crops. The project is being funded by the 1CGIAR's Plant Health Initiative, and the project has been implemented for 3 years starting from 2022. So, this is the second year of the project. And in this project, we have been primarily working in Tamil Nadu state of India, and we are focusing two most important vegetables which are quite important for the region, which is a tomato and Lablab bean. The integrated pest and disease management packages are one of the most viable options available to the farmers, because they not only reduce the use of chemical pesticides, they also reduce the production cost for the farmers. And also it enhances the biodiversity, which are beneficial in the crop production systems, and then it increases the productivity of the crop, and also it improves the quality of the produce, so that the farmers will be able to fetch a better price in the market. So, they are able to increase the income per unit area through adoption of the integrated pest and disease management packages. So, in this particular project, we have been trying to introduce the integrated pest and disease management packages for tomato and Lablab bean. And if we look at the tomato production in Tamil Nadu, obviously it is affected by a wide range of pests and diseases. And most of the varieties or hybrids that are available in the market today are having resistance to virus diseases such as the tomato leaf curl virus or other virus diseases, and even to some of the fungal diseases. But it's very difficult to find the resistant source, or it's very difficult to develop a resistant variety for bacterial wilt. And in fact, bacterial wilt is one of the most notorious diseases, because once it onsets in the field, it suddenly spreads throughout the field, and it's causing almost 100% crop loss. And it can infect the crop at any stage, for example, in the vegetative phase, or in the flowering phase, or in the fruiting stage of the crop. So, when the disease occurs at towards the middle or towards the end of the harvesting stage of the crop, the farmer is going to incur a huge amount of losses for their investment. So, what's out there to manage this particular disease? There are no pesticides. There is no viable options available. And in tomato, there are no natural resistant sources available, so that the breeders can develop the resistant varieties. So, over a period of time, what the World Vegetable Center and other similar research institutions have found is the existence of resistant sources to the bacterial wilt disease in the eggplant. And as you know, eggplant is a sister species of tomato. And then we have evolved a grafting technology. Like fruit trees, we can even easily graft the seedlings of eggplant with the tomato. So, the resistant eggplant varieties are being used as the rootstock, whereas any desired variety or hybrids of tomato can be used as the scion. The only thing is, both the seedlings have to be raised at the same time. The stem diameter should be of the same size. So, at the age of like 3 to 4 weeks, the seedlings can be used for grafting, and the grafting technology, of course, it needs a skill set, but it's very easy to train the people, even the farm workers. And then with the simple tools like the clips, the grafting is becoming quite easy, and also the grafting union is becoming very high and successful at this moment. So, in this project, we have introduced the grafting technology for tomato, and then last year in 2022, we have planted the grafted tomatoes in the field conditions. So, in this case, what we are trying to do, we take the package of technologies, we go to the farmer's field, we put the demonstration trials through the farmer participatory mode. So, the farmer is the one who is going to take care of the crop and manage the crop until the end, whereas the researchers provide the necessary technical backstopping. So last year we were able to demonstrate that the grafted tomatoes are able to overcome the bacterial wilt disease besides providing tolerance to the water logging. For example, tomato production is a nightmare in the wet season because of the water logging, which could eventually lead to wilting of the plants either due to the physical wilting or due to the bacterial wilt disease onset. So besides the resistance to the bacterial wilt disease, the tomato grafting is offering tolerance to the waterlogging conditions, offering resistance to the root knot nematode, prolonging the harvesting period. So the farmers are able to get higher yield from the tomato production. And at times, farmers are also sharing their experience, saying that the quality of the tomato fruits being harvested from the grafted tomatoes are of high and highly preferred by the buyers and the consumers. So they are fetching a better price in the market. Besides the grafting technology, we are also using the biopesticides like Bacillus thuringiensis, Beauveria baeziana or Metarrhizium anisoplia to tackle both the sucking insects as well as the caterpillar pests which are causing the fruit borer damage, right? And one of the recent invasive pest problems in tomato is the tomato pinworm or the South American tomato leaf miner. So use of the biopesticides can provide broad spectrum protection against both the tomato fruit borer Helicobacter parmigiana, and also it provides protection against the tomato pinworm Tuta absoluta, or now it's called as Thorimoya absoluta, besides protecting the other sucking insects like whiteflies, aphids, thrips, leafhoppers, etc. And then some of the fungal diseases like late blight or early blight, and then the virus diseases, they can also be managed by combining the different components of the integrated pest and disease management tools, like the use of biopesticides like Trichoderma viridae, Trichoderma harzianum, Bacillus subtilis, or Pseudomonas fluorescens. So we are trying to combine the different biopesticides, either using them as the seed treatment or seedling treatment, or even for foliar spraying of those biopesticides, combined with the grafting technology, is providing a complete solution for the production of tomatoes in a safe and sustainable manner. And besides tomato, we are also focusing on the Lablab bean, because in the recent times the Lablab bean cultivation is getting very popular among most farmers. However, the Lablab production is being hampered by a range of pests and diseases, including the virus diseases and even the pests like thrips, aphids, and pod borers. So in the past, we have a quite good experience in Southeast Asian countries where we developed the integrated pest and disease management packages for managing similar pests and diseases on vegetable legumes. Of course, not on Lablab bean, but on other vegetable legumes like yardlang bean in Southeast Asian countries. So we have brought the integrated pest and disease management package here. We are trying to adapt them to the Lablab bean through the farmer participatory trials in both the districts in Coimbatore and Dharmaburi districts. And then we have already found the IPDM packages are quite effective in terms of reducing the pest and disease incidences, boosting the yield, so that the adopting farmers are getting better price. So our main aim of this particular project is to demonstrate the usefulness of these simple IPDM packages to the farmers, and then in the next phase of the project, at the end of the 3 years, we may move to the second phase of the project, where we have been planning to scale out these technological innovations to a large number of farmers in Tamil Nadu state, so that we expect the tomato and Lablab bean producers in Tamil Nadu will be able to adopt these IPDM packages, so that they will be able to reduce the over reliance on chemical pesticides, and then they can produce the tomatoes and the Lablab bean in a safe and sustainable manner. So we can also ensure that the consumers will receive the safe produce for their consumption. So the adoption of these technological innovations are going to protect the human health, but also it's going to safeguard the environmental health because of the reduction of the chemical pesticides in a longer run. So, I hope the farmers and the extension agents will be able to spread the word to other neighbors or farmers in the neighboring districts or neighboring state, so that the technology will be adopted in a much wider manner. Thank you very much.